Hey Algebra 1, Mr. Schachter back at you with a big video here. This is method number 1 of the Schachtering methods, the GCF method. Now this is actually the most important method. This is the number 1 method you need to check when you do a problem. Every single problem we're going to do needs to be able to be checked to see if there's a GCF you could remove. So this is the big one right here. This is huge. Now, the Gcf method of factoring is basically when we find the Gcf of the terms we're working with, and we factor or divide them out of the remaining polynomial. All right? Let's do a practice problem. The first problem says to factor using the Gcf method of 7x squared minus 14x plus 28. Well, the first thing you have to do is ask yourself, what is the Gcf? Now, I don't really need to do prime factorization here. It's pretty obvious that the GCF between 7, 14, and 28 is 7, okay? Then you could look at the x squared, the x, but there is no x over here with the 28, so I'm not able to remove any x's from the problem. If 7 is the GCF, that's what's going to be removed from the problem. And like I said in the last slide, you're going to be using division now. So if you have 7x to the second power and you divide out a 7, what's remaining left is x squared. And if you take a negative 14x and you divide by 7, you're going to have negative 2x. And if you take 28 and divide by 7, you're going to have plus 4. Now, it is notable to add that even though this is the final answer to the problem, it is very easy to check your work in this section. If you multiply 7 by x squared, you get 7x squared. If you multiply 7 by negative 2x, you get negative 14x. And if you multiply 7 by 4, you get 28. So this is an awesome unit to be able to check your work. Okay, let's try another one. This one's 8x cubed plus 10x squared minus 16x. So the GCF of this problem is going to be, well, if I look at 8, 10, and minus 16, again, I don't really need to make prime factorization for these numbers because they're pretty easy. The GCF is 2. However, this problem is a little different because the x cubed, the x squared, and the x do have a GCF. Their GCF would be x to the first power. Remember, you can only pull out the smallest number. This is 3 x's, this is 2, and this is 1, so I'm only able to remove 1. All right, so the GCF is what's pulled out, and then I divide. So 8 divided by 2 is 4. In x cubed, I had x cubed, and now I'm going to basically be dividing out one of them. I'm going to be removing one of them, and so I'm left with x to the second power. Plus, 10 divided by 2 is 5. I have x squared, I remove 1x, I'm left with 1x. Minus 16 divided 2 is 8. I have 1x, I remove 1x, I don't have any x's left over. And if you check your answer by using multiplication, you will see that this is the correct factored solution. Okay?